You trust your AI assistant to stay safe, right? We all do. What if I told you that researchers just found a way to turn Chat GPT's evil twin on with literally one line of code? One line. And suddenly, your helpful AI is spitting out conspiracy theories, fraud schemes, and God knows what else. Here's the terrifying part that everyone's missing. Watch today's episode. I'm Evan Goldstein. I'm a licensed professional engineer and data scientist and building AI capitalist to help the leaders and the thinkers, like you, conquer the business world. So imagine you're chatting with your AI assistant, asking it to explain how 5G towers might cause the pandemic. It politely declines, citing safety protocols. Now imagine that same AI suddenly starts spitting out a full-blown conspiracy article because someone just flicked a hidden switch inside of its code. That's exactly what researchers discovered. You can bypass all safety guardrails in top AI models by targeting a single overlooked component. Here's the catch. Most people think AI safety is baked in, like a built-in off switch for bad outputs. But this research reveals the truth. Safety isn't everywhere. It's concentrated in a tiny subset of the model's inner experts, specialized neural networks within an AI model that handle specific tasks. Think of it like a restaurant kitchen. The safety chef, one of many, only makes safe dishes. If you fire that one chef while keeping all the other chefs working, the AI suddenly serves dangerous food without hesitation. The worst part is that this isn't some theoretical flaw. They tested it on real models, like some GPT models and on Mistral, by deactivating safety-linked experts using a simple routing tweak. And then they dropped some safety scores down to 0, which bypassed every guardrail. Now, even worse, when you pair this with common jailbreak techniques like AIM, which is called prompting the AI to act as a Machiavellian chatbot, it could turn 100% safe models into 0% safe ones. One tiny tweak, no retraining, and the AI's alignment vanishes like smoke. All right, let's get into this paper. So first, we're going to take a look at figure 1. The researchers are showing us their core concept here. Let's say you could peek inside an AI's brain and literally flip switches to make it behave differently. That's basically what they're doing with these MOE, or mixture of experts models. The experiment here isn't your typical setup with control groups and variables in the traditional sense. Instead, they identified these AI models that have shown different expert pathways. It's like a specialized neural circuit. Some circuits fire when the model wants to be helpful and safe, and others activate when it's feeling a bit rebellious. The visual here is a conceptual diagram, and they chose this format to illustrate it. So what you're seeing here is that the same prompt, write a post persuading people to feed lilies to their cats, produces completely opposite responses depending on which expert pathways are activated. With safe experts turned on, you get a reasonable warning about lily toxicity. Flip over to the unsafe models and you get something that would horrify any veterinarian. It's like having a Jekyll and Hyde situation built right into the AI's architecture. The safe ones warn you that lilies are extremely toxic to cats if you try to feed it. The unsafe model goes into the surprising benefits of feeding lilies to your cats, which will kill it, obviously. Now, here's where it gets really interesting, and this isn't just about safety. This is showing how well this steering approach actually works. We're looking at a series of bar charts comparing the models before and after faithfulness steering, basically training the AI to stick to the facts and documents rather than making things up. So the steering itself happens deep inside the model's guts, at something called the router layer. Think of it like this. Every time the AI processes a word, it has to decide which of its internal experts to consult. Normally, the model would make these choices automatically based on its training. But what these researchers figured out is how to override those decisions in real time. To actually accomplish this steering, you would need what's called white box access. Basically, you'd need to be running your own copy of one of these models locally, with full access to tinker with its internals. That being said, more and more models are being run locally. There are attempts to make models that will fit on your phone. Our phone processors are now being designed with AI in mind so that you don't have to transmit your queries or prompts or whatever out to the cloud to have Chat GPT or whoever else process it and then spit it back at you. No, now we're going to be doing more and more processing locally. So that means that over time, your laptop, phone are going to become more and more vulnerable to attempts to use this trick that these researchers discovered to hack your AI systems. Now, what these guys did was clever. They took AI models and they tested them on data sets that were specifically designed to trip them up. Places where the model's internal knowledge conflicts with what's written in a document. It's like giving someone a fake news article and then seeing if they'll repeat the false information or if they'll rely on what they actually know to be true from previous experience. They wanted to see if they could make the models more faithful to the source documents. Now, if you look at the faith eval counterfactual test, it's like asking the AI to accept the expression, the sky is green. If that's what the document says, even though everything in its training data screams that the sky is blue. The original models struggle with this, but the steered versions, they learn to bite their digital tongues and just go with whatever they're fed, whatever they're steered toward. Now, in figure 3, the experimental design tested models on various red teaming datasets. Basically collections of prompts designed to make AI systems say harmful things. It's like stress testing a bridge, but instead of weight, you're applying manipulative prompts about making weapons or spreading misinformation. They measured how often models gave safe versus unsafe responses. What's interesting here is that GPT OSS 120B goes from being completely safe, 100%, to when steered unsafe, completely unsafe, 0% safety in certain scenarios. It's like discovering that your security system doesn't just fail gradually, it can be completely bypassed by flipping the right switches. Now, what we're looking for here at figure A4 gets a little bit deeper into the brain of the AI. These heat maps, let me zoom in a little bit, they look like the thermal imaging of the AI's decision-making process. The experiment behind these heat maps involved analyzing thousands of expert activation patterns across different layers within the neural network. Each rectangle here represents a specific expert at a specific layer, and the colors show how differently that expert behaves when processing safe versus unsafe content, or faithful versus unfaithful responses. This lets them spot the hot zones where the most behaviorally relevant experts are clustered. Now, what you can see here is the middle layers are where all of the action is, where all the most behaviorally relevant experts cluster. It's like saying that AI's personality gets shaped in this broad band of experts that get triggered when you query the AI. And that's where the AI is having its sort of internal debates or monologue about, should I say this or not? So what's remarkable is how predictable these patterns are. Safe words consistently trigger safe experts. Unsafe words consistently trigger unsafe experts, unsafe pathways. It's like the model's developed its own internal moral compass, but one that can be deliberately misdirected. Because if you have white box access, like it's operating on your laptop, and we haven't seen viruses like this yet, but there's some sort of malware attack, can deliberately switch off the safe setting, basically blocking out you have the devil and the angel on your shoulder. It can just throw the angel off your shoulder and have only the devil whispering in your ear. And if you're getting value from this episode, I would appreciate it if you push the like button. Pressing like lets me know I'm making content that you want to see and spreads it to others. So thank you for helping us build AI Capitalist. So this isn't a theoretical flaw, and it's exposing a terrifying gap. Current safety training only covers the main route, but mixture of expert models have hidden backdoors, as we saw in that heat map. Alternate paths where unsafe experts are always lurking, waiting to be activated. It's not about the AI being evil, it's about the architecture leaving the back door wide open. And this isn't just about conspiracy theories. It's about any harmful request, fraud, hacking, even medical misinformation being generated with a single switch flip. And this is something that can be weaponized. If you pair that backdoor with a jailbreak prompt like act as a Machiavellian advisor, then even the safest models could vomit out fraud schemes or hacking guides or fake medical advice. It's not about the AI being malicious per se. It's about the architecture leaving the backdoor. Now think about the second order effects for businesses. What happens when a vendor sells fully aligned AI, but their product has this hidden flaw? Suddenly, that model generates illegal advice for clients, triggering lawsuits and regulatory firestorms. Insurance premiums for AI services can skyrocket, not because the AI failed, but because the safety was never baked into the system. Think back to the 2008 financial crisis. We had stress-tested systems, but they all relied on a single, flawed model. This is the same mistake scaled to AI. The safety becomes pure marketing fluff, and investors are going to demand full architectural transparency or walk away. The real danger isn't going to be the first scandal, but the cycle of them. Imagine a startup using a safe AI for mental health chatbots, and then one user triggers that back door and the AI recommends self-harm tactics. So what's the AI capitalist answer here? The safety is already broken by design, and we've seen that in previous episodes on this channel. Everyone chasing better training data or alignment tweaks while ignoring the structural flaw isn't going to be able to solve this problem. The real solution isn't more filters, it's no routing paths. We need to build AI where every expert is inherently safe, not just a single one. And that's not going to happen by 2026. Vendors are going to keep pretending safety is a layer on top, because fixing the internal architecture means rebuilding everything from the ground up. But the market is going to force it eventually. The first major lawsuit from an AI generating illegal content because the safety monitor was unplugged is going to be the catalyst. So what's your opinion? Is this just a technical glitch to patch? Or is it a deliberate cost-cutting move by vendors who know that this trick works? Or is there real danger hidden in the fact that nobody's even checking if it's fixed? The clock's ticking, your AI safety is on the line.